Okay, good afternoon to everybody. First of all, I would like to say thank you very much for the organizing committee for inviting me in order to present our project BioClean, which is coordinated by the University of Bologna. BioClean is an FP7 funded project with EU contribution of about 3 million euro. It is an SME target project, and so 27% of the European contribution is for small medium enterprises. The project addressed the call on the biotechnological solution for the degradation of synthetic polymeric material. Indeed, based on statistics performed by Plastics Europe, in 2011, about 230 million tons per year has been produced, and the EU contributed for 1/4 of such production, producing mainly 75% of the most common or most prominent plastics, including polyethylene, polystyrene, polyvinyl chloride, and polypropylene. Actually, the post-consumer waste is about 24 million tons per year, and some of this is becoming recycled, and the other is incinerated with the recovery of the energy. However, both incineration and recycling have their limits, including the expensive sorting that is required for this recycling and the production of ash and wastes from the incineration. This makes 46% of this waste plastic being disposed of in landfill. In landfill, this plastic undergoes partial degradation, photodegradation mainly, and producing smaller pieces or microplastics that can enter the food chain, and that could have toxic effect. This because of the plasticizers used, and also because of the use of these microplastics as as a vehicle of hydrophobic organic matter to the marine environment. This, of course, in addition to the effect that have these plastics on the biotic ecosystem in marine environment. So, the main objective of the project is to develop innovative, eco-efficient, pilot-scale and/or field-validated biotechnological solution for degrading, or if possible, valorizing through the reuse of the biodegradation products for the production of other useful compounds with different characteristics of plastic waste coming in from terrestrial environments, and as well as the marine environment. So, the strategy of the project consists in using waste plastics from different origins, including landfill, composting facilities, anaerobic digesters, as well as marine environment, including sediments and floating microplastics, for enriching microbial consortia or isolating pure strains that are able to degrade these plastics. And indeed, we believe that since these microbes have been in contact with these plastics, they could develop mechanisms for degrading this waste. On the other hand, we aim to select enzymes and microbes from commercial and as well as private culture collection, and use them for evaluating their capability to degrade plastics. We considered, as I said before, the 4 types of plastics that are the most produced in European Union, which are polyethylene, polypropylene, polystyrene, and PVC. We use them both as plastics and polymers. Polymers when we don't have of course, the plasticizers and the additives. Why plastics? When we have this for because some of these polymers could not be processed without additives. So we evaluated the microbial activity both on virgin non-treated polymers as well as chemically or physically pre-treated polymers, because pre-treatment has been reported to enhance the microbial degradation of polymers. In the next step, we aim to determine which are the mechanisms of plastics biodegradation, of course, considering the most promising microbes that we obtain. And with regard to enzymes, we would like to see if following tailored and specific cleaving of the polymers, we can have the degradation products as building blocks for obtaining other kind of plastics. The most promising microbes and pretreatments will be scaled up and used for development of bioaugmentation protocols as well as for demonstration in situ in Aegean Sea mainly. So, what we expect from this project? We expect to find a collection of well-characterized microbes and also enzymes that are able to degrade polymers, or at least to transfer them, not completely to use them as a unique source of carbon, but at least to transform them in other compounds. We expect to define the new pathways for the degradation of these polymers, to develop new pilot scale processes both for biotechnological and chemical and physical ones for these waste plastics. And we expect to develop also site-specific measures for mitigating plastic pollution and improving the environmental status of the agency. The BioClean consortium consists of 19 partners, among which 1 Chinese and 18 from Europe, including universities, including also research institutions, as well as 7 SMEs, and Plastics Europe and DIDISA. So actually, the project is in mid of its term, so it's we are half-period project, and what we found from work package 2, which is concentrated on the isolation of and selection of microorganisms and enzymes that are able to degrade polymers. For this, we have screened about 10 enzymes, 250 strains, including bacteria, aerobic and anaerobic ones, including fungi that have been either purchased from commercial collections or that were available in the partners' collections. And we performed isolation from waste plastics, and we considered for the enrichment of microbes about 50 different samples coming from anaerobic digester plants, from landfill, composting, a polymer production site, as well as sea environment, including Aegean and the Norwegian Sea. What we found actually is that for the polyvinyl chloride, we have reached 7 anaerobic consortia that are able to degrade polymers. So to use completely to degrade the polymer chain, not only to use the additive, as well as 4 bacteria that are aerobic. For polypropylene, we found 2 bacterial strains and 4 fungal strains. And for polystyrene, we have 1 anaerobic, 2 anaerobic bacteria, and 2 fungi. Regarding polyethylenes, we have 2 fungi and 2 aerobic bacteria that have been shown to have the ability to degrade these polymers. We didn't succeed to find actually an enzyme that is able to depolymerize, to degrade the plastics we are testing, but screenings are still ongoing. And this not only for enzymes, but also for microbial consortia, mainly anaerobic ones, as well as for other bacteria and fungi. Screening is going on because the time of degradation is very long. We are talking about of months of incubation, and especially in the case of anaerobic bacteria that need much more time compared to fungi and aerobic bacteria. So the second work package which we are concluding is the working package 4, which is dealing with the pre-treatment. And here the CNRS is involved, and they used both irradiation, UV, gamma, or X-ray, as well as thermal treatment. They used these treatments successively or in combination, and actually the physical treatments have been optimized and for each kind of polymer. On the other hand, also regarding the chemical treatments which involve the ozonation of the films, in this case, mainly the time of ozonation has been optimized. And of course, when we talk about optimization of the time of the pretreatment, we are talking about the appearance of functional groups that would help to change the hydrophobicity of the polymer and making it a little more hydrophilic, and so allow the bacteria to adhere on the surface and to perform the degradation of the polymer. One other aim of work package 4 is also to see what is the effect of this pretreatment on the biodegradation. Standard assays has been performed, and after 3 months we didn't observe very interesting changes, but this is also short time, and the assays are ongoing. So, based on results obtained in working package 2, so the microbes that we obtained, on the results of pretreatment, the most promising processes and microorganisms will be used in working package 3 in order to determine or evaluate which is the mechanism the microbes use to degrade the polymers. I mean, for example, if they are able to completely degrade the polymer, or they just use the additive, or if they degrade the polymer in using it as main carbon source or in a co-metabolic way, so they use another carbon source but they produce enzymes that could degrade polymers, and so on. So the most promising organisms found and characterized in working package 3, and the most optimized processes that show better or change in the biodegradability of the polymers will be used in working package 4 for designing pilot scale processes, of course using these microorganisms and these pre-treatment processes. And the results of the working package 4 will be for work package 3 will be also used for the development and optimization of bio-augmentation strategies to enhance the biodegradability of the polymers. So, and concerning this work package, some activities already started, although the work package is just starting, and the platform has been prepared. And here you see the cages where the plastics were put in order to evaluate the formation of biofilm and the effect of the current and so on. So it is just a control experiment, because we expect to do this with the most promising microorganisms and pre-treatment. The biodegradability under controlled composting condition is also ongoing. So what come out from work package 6 will be exploited in work package 7 for demonstrating these bio-augmentation protocols, mainly in agency and composting facility of the DISA. Another work package is the work package 9, development of policy tools supporting the marine strategy framework directive related to plastics. And also, in this case, some work has already started by EPE and Technical University of Crete Professor Nicholas Kalogerakis. And here the microplastics have been, and pellets have been collected, and they are being analyzed in order to determine which is the origin of the marine litter in that region. So other 3 work packages are in the chart of the BioClean. These include the work package 8 with the environment, evaluate the environmental and economic evaluation of developed processes, as well as the working package 1, which is on coordination and management, and the work package 10 for dissemination. So as a conclusion to this project, what we, based on what we have actually, we are aware that this project is challenging, because we need a long incubation time, we need the activity of microbes is slow. Also, we need different chemical analysis in order to detect the biodegradation of the plastic, because often one technique is not enough. We have to combine several in order to evaluate the polymer biodegradation. But this is the only way opportunity, actually at least, to evaluate whether biotechnological approach could be one of the approach to consider in management of waste plastic and marine litter. Well, I finished. I would like to thank all members of the consortium and you for your kind attention. Thank you.